Welcome back to my channel. sTVENGINEERING is pleased to accommodate you and spend some of your precious moments with me. I wish everything is alright and everybody's in God's righteous hand. For the new visitors, please like, subscribe, and share my channel. For my beloved subscribers, thank you for your undying support. What's up, guys? I hope that this today sharing of knowledge will help you in the future. Today I am presenting to you another technical information for you to enable to learn something from me and my experiences, particularly about Saudi Aramco engineering standards, procedures, material requirements, and other associated engineering mandatory requirements related to instrumentation. In today's discussion, we are about to discuss matters related to process instrumentation. However, most of the topics are more focused in the electrical requirements for instrumentation system. Don't worry. Today, I will make sure that you will learn basic instrumentation. This will serve as introduction to our upcoming detailed study in the field of instrumentation engineering. Most likely, a brief discussion about process instrumentation, which are most commonly used in our petrochemical industries. We have the following objectives: to be able to discuss matters related to SAES-J-902 and introduction to process instrumentation, to be able to know related electrical requirements for the installation of process instrumentation, and to be able to share previous experiences in the construction industry. Our outlines: introduction, we have the definition of terms, process instrumentation and controls. We'll discuss material specification, of course installation requirements, and some of the testing, SAES, and other industry standards. Instrumentation engineering is the engineering specialization focused on the principle and operation of measuring instruments that are used in design and configuration of automated system in areas such as electrical, pneumatic domains, and the control of quantities being measured. And instrumentation and control engineering is a branch of engineering that studies the measurement and control of process variables. Take note of the process variables. Instrumentation engineering is also the study of the design and implementation of systems that incorporate them. We will discuss more on details with process variables in the following slides. Instrumentation and controls are greatly parts of the manufacturing industries, petrochemical plants, and instrumentation is part of our daily life. We have so many definitions for the instrumentation, but we can simply define it in one word as automation, or we can say controls. High demand for engineering professional is found in the field associated with the process automation. Specialization include industrial instrumentation, system dynamics, process control, and control systems. In addition, technological knowledge, particularly in computer system, is essential to the job of an instrumentation and control engineer. Today we will be focused on industrial instrumentation in the petrochemical plant, about process controls. Our engineers technician, and other trade workers like electrician, instrumentation technician, and other personnel who wish to work with instrumentation field will be benefited in this brilliant topic. In this vlog, I am going to teach you with the best of my knowledge. However, for better understanding, if you have the chance, it is important to take some more trainings in technology related topics, like include the human computer interaction, or HMI, which is human machine interface, programmable logic controller, or PLC for short, and supervisory controls and data acquisition, or SCADA. Guys, these trainings, I have all of these trainings, especially during at my early stage in working as instrumentation. So this is this kind of seminars, trainings, plus this type of knowledge sharing is essential to your development. We have the definition of terms. We have two sets of definition. One from Saudi Aramco engineering standards under SAES-J-902, which is the electrical system for instrumentation, and others are standard terminologies of process instrumentation engineering. SAES-J-902, this standard establishes the design criteria for the installation of power and wiring system for electrical instrumentation. All the requirements for power and control wirings are under this engineering standard. This standard is associated with other Saudi Aramco engineering standard, like the one we have discussed before, the SAES-P104, which is the wiring methods and materials, and the SAES-P-111, which is the grounding, and other associated standards and engineering procedures. These are all relevant standards for instrumentation. And the National Electrical Code, which is NEPA 70, is also one of the mandatory standard references. So we have some definition from SAES-J-902 regarding the circuit. We have the class 1 circuit, a circuit complying with National Electrical Code and EC Article 725 Part 2. We have the class 2 circuit, a circuit that complies with National Electrical Code Article 725 Part 3. And we have the class 3 circuit, a circuit that complies with National Electrical Code Article 725 Part 3. These class 1, 2, 3 circuits, these circuits are covered by the National Electrical Code Article 725, and these circuits are considered instrumentation circuits. Particular service of these circuits are remote control, signaling, and power limited circuits. Power limited circuits are also being used in fire alarm system. Therefore, in Saudi Aramco, the fire alarm system are considered under the instrumentation. For the further understanding of power limited circuits, these circuits shall be supplied from a source that has a rated output of not more than 30 volts and 1000 volt amperes. Therefore, these types of circuits are considered instrumentation wirings. We have the data link. Any information channel used for connecting data processing equipment to any input, output, display device, or other data processing equipment. Drain wire. In a cable, the non-insulated wire in intimate contact with a shield to provide for termination of the shield to a ground point. This typically found in instrument cable. This non-insulated wire used to protect the circuit from noise and other magnetic disturbances. We have the home run cable. A cable typically multi-paired or triad, extending between the field junction boxes and marshalling cabinets in a control buildings. These are the main cables normally found installed in a home run fence. We have definition for severe corrosive environments. Because we're gonna define severe corrosive environment because there is a special material specification for severe corrosive environments in Saudi Aramco. For the purpose of this standard, only severe corrosive environments include outdoor offshore location, outdoor onshore location within 1 kilometer from the shoreline of the Arabian Gulf, all of the Rastonor refinery and terminal, all of the Yanbu refinery and terminal, and within 3 kilometers from the shoreline of the Red Sea. So these are the severe corrosive environments in Saudi Aramco. In addition, areas where caustic chemicals are being handled or stored are also considered as severe corrosive environment. So we proceed with the process control standard terminologies, or these are part of the process control. So we have the process variables, or variables that can be measured and controlled. These variables are flow, pressure, temperature, and level. These are the basic terms that you should know if you are interested in instrumentation. So regarding the process variables, we have two kinds of process variables. One, measured variables. Measured variable, a variable that can be measured or controlled. This is like the pressure, temperature, flow, and other measured variables. And we have the manipulated variables. These manipulated variables are variables which usually affects the measured variables. Like for example, the quality of water, the length of cable. So this will all affecting the quality of the measured variables. So we have the transducer / sensor, or sensor transducer, because sometimes the sensor is a combination of a transducer. A device that used to receive and responds to a signal or a stimulus. Transducer used to transform one kind of energy to another. And we have the transmitter. So we have several transmitter in the process instrumentation, like pressure transmitter, flow transmitter, pressure transmitter, level transmitter. So the definition for a transmitter usually converts the sensor output to signal level appropriate for input to a controller. So the transmitter sends signal to the controller, and the transmitter receive signal from a transducer. We are about to discuss the elements of instrumentation. So we have 4 elements of instrumentation. We have the primary element, measuring element, controlling element, and final element. We're gonna define its element, and we're gonna provide you some example of these elements. So primary element, device that senses changes in the value of measured variables. The primary element is the name given to the device which senses changes in the value of measured variables, like the thermocouple, or a faceplate, or a float. Measuring element, a device that receives the output of primary instrument and used as indicating or recording. So the measuring element, we can say the indicator or a recorder. Controlling element, device which used to regulate the variable sensed by the primary instrument. And last, we have the final element, device that varies the process as desired by the controller. So example of final element, these are like power cylinder or control valve. So we have general requirements for instrumentation. These are all electrical requirements for instrumentation. So for the design and installation of power and wiring system for instrumentation shall be in accordance with NFPA 70 National Electrical Code, unless otherwise supplemented by the Saudi Aramco Engineering Standard. Foundation field bus wiring system shall be installed in compliance with SAES-J-902 foundation field bus system. Electrical and electronic equipment in hazardous areas shall meet listing certification requirement as specified in SAES P 100 in the National Electrical Code. Paragraph 5.4, intrinsically safe system. Intrinsically safe system shall only be used in Zone 0 hazardous areas, or when the vendor's standard product offering is supplied as intrinsically safe. Intrinsically safe system shall be installed in compliance with SAES-J-903, which is the intrinsically safe system. Fireproofing of cables in fire hazardous areas shall be in accordance with SAES-B-006. Fire alarm system shall be installed in accordance with this standard, the National Electrical Code, Article 760 and NFPA 72. NEC or National Electrical Code, Article 760. These articles covers the installation of wiring and equipment of fire alarm system, including all circuits controlled and powered by the fire alarm system. So you should take note of this article. Article 760 of the National Electrical Code is fire alarm. Regarding the intrinsically safe system, IS system assure equipment involved can be installed in classified location as defined in National Electrical Code Article 500. We have the requirements for the cable ties. All cable tie used in the field shall be nylon coated 316 stainless steel. And we have the example brand, the Conduit MLTC series. All cable ties used inside of enclosure and buildings like the field junction boxes, marshalling cabinets, control rooms, and process interface buildings shall be weather resistant nylon cable ties with a stainless steel barb. The cable tie shall have a maximum continuous use temperature rating of 85 degrees C or higher. So the cable ties is very important in instrumentation, because if you use poor quality cable ties, this will not last long. So this will affect your cable dressing, and it will be damaged easily by the temperature. Regarding the conduit and cable sealing, so this is a special process in electrical. Take note of that. Conduit and cable sealing shall be installed in accordance with National Electrical Code, Article 505, except as specified in Section 6.2 and 6.3. For the armored cable sealing, certified to improve Type D cable gland using a compound barrier seal. Conduit sealing for individually shielded twisted pair tried cable. When individually shielded twisted pair cable passes through a conduit seal, it should be treated as a single conductor and shall be sealed with the outer jacket intact. In addition, the cable and within the enclosure shall be sealed by an approved means. So this is required method statement or procedure, because this is a special process in electrical installation. We have enclosure material specification requirements for all the areas. Enclosure for instrument in outdoor for plant areas shall be NEMA Type 4 in accordance with NEMA ICS 6 and NEMA 250 or IEC 60529 Type IT65. So these are the requirements for the outdoor plant areas. Enclosure in severe corrosive environments shall be NEMA Type 4X or IEC 60529 Type IP66. So this is a much higher rating compared to the first one, because this is severe corrosive environment. NEMA Type 4X is stainless steel. The field junction box in a Class 1 Zone 2 location and in non-hazardous areas shall be a single door NEMA Type 4X or IEC 60529 Type IP66 box. There is a box construction for the junction boxes. It shall be 316 stainless steel body, door and hardware, continuously welded seam, finish mount, continuous stainless steel hinge with a removable pin, stainless steel captive clamps. There is a data print packet on the inside of the door, external mounting brackets, collar stud for mounting side panel, ground stud for terminating alternating current safety ground wire. Painted steel panel. In severe corrosive environments, stainless steel panels shall be used. All junction boxes shall be mounted vertically. Instrument enclosure in junction boxes having an internal volume exceeding 2,000 cubic centimeters shall be provided with the Type 300 series stainless steel breather and drain fittings or a combination breather and drain fitting. So this is very important. During the installation, you're gonna find junction boxes which does not require breather or drain breather, because we have the requirements of from 2,000 cubic centimeter exceeding 2,000 cubic centimeter. These are the junction boxes which requires drain breather. or a combination, drain or breather, or a combination of breather and drain fittings. So please take note of that. Conduit and conduit fittings and support, these are all under size P104. We have discussed these things in size P104. You can read it in section 8. An outdoor installation conduit bodies and fittings shall have threaded cover openings. A conduit outlet butt shall be installed within 18 inches of the field device. The cable to the instrument shall be looped of one or more times within this fitting. The sizing of the conduit outlet shall take into account the bending radius of the cables. For the flexible conduit, shall be used at the instrument end of the conduit to provide isolation from vibration, protection against thermal expansion of the rigid conduit system, and ease of maintenance. So these are the reason why we need the flexible conduit. So in the plant areas, it's not simply flexible conduit, it is a liquid type flexible metallic conduit. So we gonna replace the rigid steel with the flexible conduit at the end of the instrument because of the following reason: isolation from vibration, protection against thermal expansion of the RGS conduit, and for the easy maintenance. For Class 1 Zone 1 location, flexible fittings listed for the area shall be used like cross hinds, ECLK. For Class 1 Zone 2 location in unclassified areas, the flexible conduit shall be liquid type flexible metallic conduit. Shall have a sunlight resistant, cover with resist oil and chemical breakdown, and shall be rated for temperature not less than, equal or greater than 90 degrees C. So this is the requirements of the liquid type flexible conduit. So the cable trays we discussed also in size P104. This is the specification shall be as per NEMA BE1. The tray installation shall be as per NEMA BE2. And you can check it in size P104 section 9 cable tray system. So we have the connection at field instrument and junction boxes. All connection at the field instrument shall be made on screw type terminal blocks. So we're gonna use terminal blocks. Wire nuts and spring nut type terminals shall not be used. Instrument with integral terminal block shall be connected directly to the field cable. So only terminal blocks is allowed. Wire nuts like the one we use in lighting fixtures is not allowed. If the instrument is fitted with factory sealed fly leads, then they shall be connected to a screw type terminal block installed in a GUA conduit fittings. Typical installation arrangement is shown in library drawing. This is DC 95003. This is electrical connection for field mounted instruments. For armored cable installation, refer to section 13.1.1.2. The outer jacket of shielded twisted single pair triad cable shall be left intact up to the point of termination. Drain wires and mylar shield and shielded cable shall be cut, insulated with heat shrink sleeve at the field instrument unless otherwise specified by the manufacturer. So this is if you are a instrument technician, you know the termination. This is the very important in termination because you're gonna find the drain wires and the mylar shields on shielded cables, and you should know what to do, and this is the requirements for that. So you don't need to terminate those wires, the drain wires. You're gonna put the cap so that it should not be touched the inside the boxes, should be insulated only. So this is very important. For the inspection, And for the engineers, these are all important. So you should know these things, and you should be very careful of this thing, because this will affect the signal. Let's continue. Conduit and cable entries to fill junction boxes shall be through the bottom. Top entry is allowable provided a drain seal is installed in the conduit within 18 inches of the enclosure. Side entry within 6 inches of the bottom shall be permitted only when space limitation dictate. The number of conduit entries shall be kept to a minimum. All unused entry ports shall be fitted with approved plugs. Conduit entries shall be through gasketed hubs except in explosion-proof installation where the connection shall be through threaded connection. So these are all connection at field junction boxes. So we have the standard color coding. Power and control signal wiring shall be color coded as follows. For the AC supply, phase is black, neutral is white, ground green or green with yellow tracer. For the DC, positive is red or red sleeve or any other color except green. Negative will be black or black sleeve or any other color except green. So for the signal, positive is black, negative is white. For the signal triad, positive is black, negative white, and the third wire is red. So for the thermocouple, the color coding of the thermocouple will be as per ANSI MC 96.1. So these are the standard color coding of the power and signal wiring. So gentlemen, you should know this color coding because this is very important. So testing of instrument cable. Of course, instrument cable will be subject for meager or insulation tests. Depend on cable insulation, cable type. Of course, we're gonna do continuity tests to check the integrity of the loop or the circuit, and we have the loop checking as well, continuity of the loop and devices, and we're gonna do the signal simulation, including the process controller. We have also pull-up tests, final checking of termination of wiring. This is the process overview of instrumentation. The sensor or transducer are directly in contact with the process variables. Then output of the sensor turn input for the transmitter. For transmitter, electronic module process the input from sensor or transducer. Convert instrumentation signal normally in the form of analog 4 to 20 milliampere. Then the controller takes the necessary action as required by the process setting. This is also called a block diagram of instrumentation process. This picture shows a piping and its installed process instrumentation. These are the instruments normally found in the PNID. PNID stands for Piping and Instrumentation Diagram. Regarding the PNID, looking at the PNID, you will see all the installed instrumentation related the piping, other process information like the process flow or flow direction is indicated as well. The service equipment, line number, process line, associated equipment, and other information can be found in the PNID. Understanding the PNID is essential for an instrument engineer, as well as reading symbol and other standard terminologies that you have to know in PNID. some of these terminologies like upstream, downstream, header, bypass, online, offline, and so many other terminology that you will encounter in instrumentation. These are Saudi Aramco standard instrumentation. We can make detailed discussion for the following instrumentation: flow instrumentation, level instrumentation, precious instrumentation, gas detection, and even the fire alarm system. These instrumentation are covered by another Saudi Aramco engineering standards. However, as discussed, the electrical requirements are all under SAES-J-902. So guys, thank you for watching my channel. We have another episode of learning experience, and I hope that you learn something from it, and I'm sure you can apply it in the future, and I will be having more vlog in instrumentation, and we're gonna discuss one by one. So guys, bye bye from now, and thank you, and good luck. Be safe, and God bless.